Good morning, one and all present here. This is Amit Kumar Singh, and welcome to my class on reminder theorem. So, guys, I really request everyone that if you have not seen my previous video on reminder theorem, then this will be would go above your head, because the thing which is important for you to do this session is that you should be thorough with the concept on Euler theorem. You should know what is Gaussian number. You should know what is about Chinese reminder theorem. You should know about Fermat-Little theorem. You should know about Wilson theorem. If you have seen my previous video on reminder theorem, then only this will make more sense to you. Or if you are aware about the basic logic on how we works on reminder theorem, then this can be beneficial for you. This would be this session I can consider as the part two session of my reminder theorem. Already I have made one video on reminder theorem. Already you can find that video link in the description. Also, you can, if you search on my channel, you will get the class on reminder theorem. So make sure that you watch that class before and then you come and see this session. Then only it will make more sense to you. Thank you, everyone. Then let's start the class. So one by one, I'll try to only focus on solving the numerical. Same problem you can do in many ways. So you can have your own way of getting the answer. Once you see the problem, you can pause the video and then you can try from yourself, from your end. And in case of any doubt, you are most welcome to watch my part of solution. But everyone do this problem differently. So again, it's all depend on you how you want to approach a given problem. Okay, guys. So let's start the class then. This is the first question. What is there on the screen? So you need to find the reminder when 18 to the power 22 to the power 10 when you divide by 7. So what would be the reminder? So I'll tell you my way of solving this problem. I'll try to focus more on Euler theorem to get the answer. So if this problem is like this, 18 to the power 22 to the power 10. If I divide this by 7, so my question is that what is the remainder? Okay, fine. So fine. So if I we know that our divisor is 7 and 7 is a prime number. So the Gaussian number of 7 would be 6. Okay, so that means, so the next step would be, I can say 18 to the power 6. Okay, divide by 7. So 18 to the power 6, any power of that will give the remainder 1. You all know that. Okay, but there's a problem that any power of that, when I see, so here is the power called 22 to the power 10. Okay, so I need to break 22 to the power 10 in the multiple of 6. Okay, so if I have to break 22 to the power 10 in the multiple of 6, so other way I have to divide 22 to the power 10 divided by 6. Okay, then I need to see what is the quotient, but quotient is not important to me. What I am interested, what would be the remainder. So probably whatever is my remainder, I'll take that as a power. Okay, so whatever is the remainder from here, I'll use that as a power here. Okay, so if you use basic understanding, whenever how we split the powers, the basic concept on indices. So that is what I'm talking about here. So what is the Gaussian number of 6? So 6 is 2 into 3. So the Gaussian number of 6, if I want the Gaussian number of 6, so that would be 6 into 1 minus 1 by 2 into 1 minus 1 by 3. So I can write 6 as 1 by 2 into 2 by 3. So probably the Gaussian number of 6 would be 2. So, but again, whenever we apply Euler's theorem, they should be co-prime to each other, but they are not co-prime to each other. So what I will do in 1 minute, they should be co-prime to each other. So I can make it more simpler. I can make this more simpler. So here my number is like 22 to the power 10, and I'm dividing this by 6. So I'm more interested with remainder part of this. Okay, so if I divide 22 by 6, so I get 4. So 4 to the power 10 divided by 6. So okay, so 4 to the power 10 divided by 6. Again, so they are not co-prime to each other. Okay, so what I can do, I can write 6 as 2 into 3. Okay, Okay, so I can write 6 as 2 into 3. So if I write 6 as 2 into 3, so when 4 to the power 10, so when I divide by 2, so what is the remainder? So you know that remainder would be 0. Okay. Similarly, if I divide 4 to the power 10, divide by 3, so what is the remainder? So the remainder would be 1. Okay, so 4 I can write as 1 to the power 10. Okay, so 4, if I divide 4 by 3, what I'll get a reminder? I'll get a reminder as 1. So 1 to the power 10. So the remainder would be 1 here. I hope you're understanding. So ultimately, you need to think about a number. Ultimately, you need to think about a number. So if you can express this number like this, 3k plus 1. So when you divide by 3, you're getting a remainder 1, but it should be divisible by 2. So you think that number, you think that as a number. So if I take k as a 0, so the number is 1. So that is not divisible by 2. If I take k as 1, so 3 plus 1, you get 4. So you got a number called 4. You got a number called 4, and 4 is divisible by 2. Okay. So that way you can think this number. That way you can think that value as like this way. So the n value here, here the possibly the value of n. So that remainder is basically 4. So you can put the 4 here. So you can put that 4 here. So here you know that this will give, you know that this end will give the remainder 1. You know that this end will give the remainder 1. You know that this end will give the remainder 1. So what left is 18. So this is 1. It will is giving remainder 1. This is 18 to the power. How much you're getting? 4. 18 to the power 4 divide by 7. Okay. So 18. So 18 is divisible by 7. So like when I, if I take 18, so 80, if I write this number like 18 into 18 into 18 into 18, if I divide them by 7, so every time when you divide it by 7, every time like 7 twos are 14, so you get 4 into 4 into 4 into 4. So this is, so this you can split as 4 to the power 4 by 7. So what is the remainder? 4 to the power 4 divided by 7. So what is the remainder? So you know the Gaussian number of 7 is 6. So that will not work here. So 4 to the power 1 is 4. When I divide by 7, remainder is 4. 4 to the power 2 is 16. When I divide by 7, remainder is 2. 4 to the power 3. 4 to the power 3, 64. When I divide, I get the remainder 1. 4 to the power 4 is 256. Okay, so when I divide by 7, so I'll 21, 36. So 4 to the power 4 is 20. 4 to the power 4 is 256. So this is 46. I'll get a reminder call 4. Okay, so ultimately, what is your reminder? So here, what is your reminder? The reminder for you is 4. You got the logic, right? So this logic you need to use ultimately. So the answer for this problem is actually 4. Okay, so this is the first problem. Fine. So you can have your own way of getting the answer for this problem. Okay, then we can do the another problem. You can see the next problem. Find the remainder when 19 to the power 23 to the power 24 is divided by 16. So your problem is like this: when 19 to the power 23 to the power 24, if you divide this by 16, so I can write, if I divide 19 by 16, I'll get 3. So 3 to the power 23 to the power 24, when you divide by 16. Okay, so what is the Gaussian number of 16? 3 and 16 are co-prime to each other. So the Gaussian number of 16 is what is, you can write 16 into 1 minus 1 by 2, you get as 8. Okay, so I can write as this is 3 to the power 8. Okay, so 3 to the power 8 into 3, so divide by 16. So now what is matters to me, that here you can see I'm at the Gaussian number is 8. So ultimately what matters to me is that when 23 to the power 24, if that is divided by 8, so what is the remainder? So that is what I'm interested about. So that I'm gonna put it here. Okay, so here when I see this, so 23. So when I see 23, I can write 8 3s is 24. So So 23 I can write, it's giving a negative reminder of -1. So -1 to the power 24 divide by 8. So this will give you +1. So we are getting a reminder of +1. So here I can, so this part anyway is giving you reminder of 1. So this is what, this is giving reminder 1. This is 3 to the power 1 by 16. So the answer for this problem would be 3. Fine. So these are easy way of doing the problem. You can solve the problem. I'm using a Euler's theorem. So whatever the concept of Euler's theorem we know, so I'm just using them to solve this problem. Now you can see question number third. So what is the reminder when 32 to the power 37 to the power 32 is divided by 9? So the next problem is question number third. So the next problem is that when 32 to the power 37 to the power 32, if you divide this by 9, so what is your reminder? So this is a problem. Again, same logic I'll use. 32 if I divide by 32 if I divide by 9, 32 if I divide by 9, so what would be the reminder? The 9 threes are 27, so 27 means 5. So this is 5 to the power 37 to the power 32 divided by 9. Okay, now 5 and 9 are co-prime to each other. So the Gaussian number of 9 would be 9 into 1 minus 1 by 3, means 9 into 2 by 3, means 3 2s are 6. So the Gaussian number of 9 is 6. So this I can write 5 to the power 6. So here what power will I take? And so that will give me the value when I'll divide it by 9. So the power I'm taking as 6. So I need to check 37 to the power 32 when I divide by 6. So what is the remainder? Okay, so 37, you know that 6 are 36. So when 37 is divisible by 6, always you get a remainder 1. 1 to the power anything, you get 1 only. So ultimately, this 5 to the power 6 to the power anything, that is giving you remainder 1 only, and this is 5 to the power 1, that divide by 9. So ultimately, you are getting 5 by 9. Okay, so the remainder here for this problem is 5. Right. So you should be thorough with the concept of Euler's theorem. If you are good with the concept on Euler's theorems, you can solve this problem very fast. If you have any doubt about Euler's theorem, so please once revise your concept on Euler's theorem before you watch this video. Okay, so then you can see the next problem. Find the remainder when 14 to the power 17 to the power 22 is divided by 11. So you can see the next problem. So when 14 to the power 17 to the power 22, if you divide by 11, so 14 divided by 11 is 3. So I can write 3 to the power 17 to the power 22 divide by 11. Okay. The quotient number of 11 is 10. So I can write 3 to the power 10. Okay. To the power x into 3 to the power r, that should be equal to 11. Okay, now so what power, what power, so what power can I consider? So ultimately I need to divide 17 to the power 22, that I need to divide by 10. I need to know the remainder. Okay, so any number if you divide by any number, if you want to divide by 10, so ultimately you have to find the unit digit. Okay, so ultimately you have to find the unit digit. So the unit digit here would be 9. Okay, so here the unit digit would be 9. So even then I can write this as 7 to the power 22 divided by 10. Okay, the quotient number of 10 would be, quotient number of 10 would be, what is the quotient number of 10? So that will be 10 into 1 minus 1 by 2 into 1 minus 1 by 5. So that is 10 into 1 by 2 into 4 by 5. So the quotient number of 10 is 4. So I can write 7 to the power 4 to the power 5 into 7 square by 10. Okay, so that this end will give you 1. This is 49. So 49 divided by 10. So what is your reminder? So that is 9. Already I told you before only, because I use the unit digit. So the how to find the unit digit of x to the power n. So I use that. So 7 as a unit digit, follow the power cycle of 4. So that logic I use. So that I told you before, but again, the reminder theorem also I told you the same thing. So here the reminder is 9. So that 9 I'll put it here. So this is 3 to the power 10. This is x into 3 to the power 9 divided by 11. So here this part doesn't matter to me because this is anyway will be 1 only. Okay, so anyway this part would be 1 only. So I'm just interested that 3 to the power 9 divided by 11, what is the remainder? So I'm interested on 3 to the power 9 divided by 11, what is the remainder? So 3 to the power 1 is 3. If you divide by 11, that is 3. So 3 to the power 2 is 9. If you divide by 11, you get 9 or minus 2. Okay, 3 to the power 3 is 27. If you divide by 11, you will get 5. Okay, so 3 to the power 4 is 81. If you divide by 11, you will get a remainder called 4. Okay, 3 to the power 5 is 243. So if you divide by 11, so you get a remainder 1. Okay, so 3 to the power 5 is giving a remainder 1. So ultimately, I can write 3 to the power 9 as 3 to the power 5 into 3 to the power 4. So the answer would be 4. You got it right. So ultimately you want this as a reminder, no? So you want, so 3 to the power 9, you can write 3 to the power 4 into 3 to the power 5 divided by 11. So 3 to the power 5 will give a reminder 1 and 3 to the power 4 will give a reminder 4. So the answer for this is 4. Clear? Fine. So we'll go to the next problem. So you see the question number 5. You see the question number 5. Find the remainder when 38 to the power 33 to the power 39 is divisible by 11. So find the remainder. Reminder. This is question number 5. When 38 to the power 33 to the power 39, if you divide by 11. So the question number. Okay, 38 first I'll divide by 11. So 33, 11 3 is a 33. 33 plus 5, this is 5. So 5 to the power 33 to the power 39 divide by 11. Okay, okay, fine. uh, okay, so what is the tuition number 11? The tuition number 11 is 10. So ultimately what you need to think, you need to think that when 33 to the power 39 divisible by 10, so what is the remainder? So ultimately I need to think that when 33 to the power 39 is divisible by 10, then what is the remainder? So 33 to the power 39 means 10, 10 3s are 30. So this is 3 to the power 39 divided by 10. So 3 to the power 39. 3 again follow the power cycle of 4. So 39 means what? 7 will be the remainder. So 7 will be the remainder. So here the 7 will be the reminder you can use. So 7 is the remainder. So you can write this as, so this part, this is 5 to the power 7 divided by 11. So this end, anyway, this will give a reminder 1. So I'm just bothered about this. So 5 to the power 7 divided by 11. What is the remainder? So you need to think about that part. So you know that if the number is 5, so the remainder, if you divide by 11, that is 5. And the 5 square means 25. If you divide by 11, remainder is 3. 5 threes is 125 to the power 3 is 125. When you divide by 11, your remainder is 4. Okay, then this is 625. 5 fours are 20. 20 means 9. This is the remainder. Then 5 fives are 3125. So 9 fives are 45. Remainder would be 1. So 5 fives are 5 to the power 5 is 3125. No? 3125. So 3125 22. 92, 92, 45, 1. So the remainder is 1. So 5 to the power 5 is 1 and 5 to the power 4 is 9. So the answer is, so you can write this as 5 to the power 5 into 5 to the power 5 to the power 7. You can write as 5 to the power 5 into 5 to the power 2 divided by 11. So 5 to the power 5 when divided by 11, remainder is 1. Okay, 5 to the power 2 is 25. 25 divided by 11. So the remainder is 3. So the answer for this is 3. Okay, so we'll go ahead. So same concept. I'm just solving all the problem from Euler's theorem. Hmm. So which question I have done till now? Question number 5 I have done. Okay. Hmm. Now question number 6. We'll do question number 6 now. Question number 6. Find the remainder when 31 to the power 31 to the power 31 divided by 9. So find the remainder when 31 to the power 31 to the power 31 if you divide by 9. So find the remainder. So this is the problem. So now 31 divided by 9. So you will get 4. 4 to the power 31 to the power 31 divided by 9. So what is the remainder? Okay, so so here, so what is the Taussian number of 9? The Taussian number of 9. What is the Taussian number of 9? So the Taussian number of 9 into 1 minus 1 by 3 means 9 into 2 by 3 means 6 is the Taussian number. So you can write 4 to the power 6 into 4 to the power r. So what you need to do, you need to check when 31 to the power 31 divided by 6. So what is the remainder? So the answer would be 1 only. So that very easy. So because 31 when divided by 6 will give a remainder 1, and 1 to the power anything will give a remainder 1. So this is 4 to the power 6 to the power x into 4 to the power 1 divided by 9. The answer is 4. Very simple. Now the question number 7. So now we'll try to solve question number 7. So find the remainder when 17 to the power 193 is divided by 51. Find the remainder when 17 to the power 193 when you divide by 51. So I can write 51. I can write 51 as 17 into 3. Okay. So what I will do, I'll find the remainder. I'll find the remainder when 17 to the power 193 when it is divided by 17. Gradually, I'll find the remainder. So gradually, I'll find the remainder. I'll find the remainder when 17 to the power 193 when it is divided by 3. Okay, so 17 to the power anything when divided by 17. So here the remainder is 0 only. Okay, so now doing this, so this is nothing but you can write 2 to the power 193 divided by 3. Okay, so because 3 5s are 15, so remainder is 2. And then you know that 2 to the power 3, 2 to the power 6, 2 to the power 6 is how much? 2 to the power 6, 64. 64 means, so 2 to the power 6 will give a remainder 1. So 2 to the power 6, so this is 3 za, 18 over 13. 13 means 2 za into 2 to the power 1 divided by 3. Okay, so the remainder here is 2. Okay, so you need to find a number. You need to find a number which should be divisible by 17, but when it divide by 3, it will give a remainder 2, and it should be divisible by 17. So that is your answer. Okay, so randomly put the value of k. This is what we are using Chinese remainder theorem. So randomly put the value of k. So 3, if I put k as 15, so k as 5, so 5 into 3 15 plus 2 17. So the answer for you is number is 17. So the answer or reminder for this problem is 17. Okay, this is the way how we should do. Then the next problem, this is Chinese remainder theorem. Already I explained what is Chinese remainder theorem, how will you solve in my video, in my previous video. I hope you have already seen that. Now, in this question, if you see this question, what you have to do when any number divide by 100, you have to find the last two digit of a number. Okay, 4 to the power 100. So 4 to the power 100, I can write 2 to the power 200. So 2 to the power 200, when you divide by 100, what is the remainder? So here, if I'm asking you what is the remainder, I'm asking you what is the remainder. So 2 to the power 200 when you divide by 100. So any number you divide by 10, you have to find the unit digit. Any number you divide by 100, you have to find last two digit. And if you see my video on how to work on last two digit, so 2 to the power 10, 2 to the power 10 to any even power will give you the last two digit as 76. Okay, that already I explained in my previous videos. So why that, why also I explained, because 2 to the power 10 is 1024 and 1024 last two digit is 24, and 24 to the power any even power will give 76 only. So this I can write as 2 to the power 10 into 20 divide by 100. So 2 to the power 10 divide by 20, the last two digit it will give 76. Okay, very simple. If you want, we can do it by remainder theorem and all, but unnecessary, that would be the wastage of time. Okay, so that way you can do and you get the answer very easy. Now, this question, find the remainder. So this is again, is all a Chinese theorem based problem. Okay, so question number 9, you can see. The question number 9, you can see that is 65 to the power 39 to the power 80. When you divide by 39, I can write 65 to the power 39 to the power 80. So I can write as 3 into 13. So what I'll do, I'll find the remainder. I'll find the remainder when 65 to the power 39 to the power 80 when you divide by 3. Okay, that is the first part I'll do. Then I'll find the remainder when 65 to the power 39 to the power 80 when divided by 30. Okay, then I'll based on these two reminder, I'll try to find the number. Okay, so what is the two? So 65, 65, 65, 63. So 63 means you can write 2 to the power 39 to the power 80 divide by 3. Okay, so then you know that 2 to the power 6. So you know that 2 to the power 6 is 64, and 64 divided by 3 is 64 divided by 3 is giving remainder 1. So means my work is done. So I need to see 39 to the power 80. When I divide by 6, what is the remainder I'll get? So 39 to the power 80. When I divide by 6, what remainder I'll get? 6 6 are 36. So 3 to the power 80. When I divide by 6, what remainder will I get? I need to see that. So 3 to the power 80. When I divide by 6, what remainder will I get? Okay, so they should be co-prime to each other. So the 3 and 6 are not co-prime to each other. So I'll see the power of 3. 3 to the power 1 is 3. 3 to the power 2 is 9. That give a remainder 3. 3 to the power 3 is 27. So 3 to the power anything I'll take, I'll get a remainder 3 only. 3 to the power anything I'll take, if I divide by 6, I'll get a remainder called 3 only. So here 3 to the power 1 will give a remainder 3. 3 to the power 2 is 9. If I divide by 6, I'll get a remainder 3. 3 to the power 3 is 27. If I divide by 6, so I'll get a remainder 3. 3 to the power 3 is 27. 3 to the power 3 is 27. Then 27 divided by 6 is 3. Then 3 to the power 4 is 81. 81, again reminder 3. So 3 to the power anything, if you divide, you will get a reminder called 3 only. So here, so this is 2 to the power 6 to the power x and 2 to the power 3, and when you divide by 3, so this is 8 divided by 3. So here the remainder is 2. So here the remainder is 2. Okay, if you divide by 13, so 13, 65 is directly divisible with 13, so the remainder here is 0. So you have to find a number which is divisible by 13, and with 3 that gives a remainder called 2. So 3k, I can write that number is 3k plus 2, and that should be divisible by 13. So find the number. Okay, so k k4, so 14, then k5, 17, k6, 20, k7, 23, k8, 26, k8, 26. So if you take k8, so here if you take k8, so your number is 26. So 26 is your final answer. So your answer or the remainder for this problem is 26. Okay. So this is Chinese remainder theorem. Already I have started discussing that in my previous video. Okay. So next problem, when 85 to the power 19 to the power 53 when divided by 51. So 85 to the power 19 to the power 53 when you divide by 51. So I can write 85 to the power 19 to the power 53. You can write as 3 into 17. 17 into 3. Okay, so you find the remainder when 85 to the power 19 to the power 53 if you divide by 3. Okay, so so 8. So this is 25. That you'll get a remainder 1 only. You'll get a remainder 1. So 84. So 84. So 84 is divisible by 3. 85 will give a remainder 1. Okay, so next end is 85. Again 85 is divisible by 17 also, no? So 85 is also divisible by 17 also. So it will give a remainder called 0. So you need to find a number. So your answer is your remainder. That answer is the number which when it divide by 3 give a remainder 1, and it is divisible by 17. So it is divisible by 17. So uh, mm, 6, 7, 22, 8, 25, 9, 28, 10, 31, 11, 34, 11. If I take 11, k as 11, so n you get as 34. N you get as 34. That is your answer. So the answer for this problem is 34. Then now see this question number 11, everyone. By that time I'll drink water. Now see this question number 11, everyone. Try to solve this question. How will you solve this question? Question number 11. So the question number 11, that is 6 to the power 83 plus 8 to the power 83 when you divide by 49. So they want the remainder. So when you divide by 49, what is the remainder? So you need to think on that part, how you can solve this. So question number of 49 is 42. Question number of 49, 49 into 6 by 7. So 49 into 6 by 7. So 49 into 6 by 7. So 7 6 are 42. So that 42, that logic. So 83. So 42 if I remove, so you get how much? You get 41. Okay. So you need to check that you can try with divisibility. You can try with divisibility. That is the one thing you can do. Or what you can do, you can apply binomial theorem. So a to the power b to the power n. If you apply binomial theorem, that is a to the power n plus nc1 is a to the power n minus 1 b plus nc2 a to the power n minus 2 b square plus nc3 a to the power n minus 3 b cube, like this till nc n minus 1 a to the power 1 into b to the power n minus 1 plus b to the power n. This is binomial theorem. You can apply that. So 6 to the power 83 I can write as 7 minus 1 to the power 83. Okay, so this I can write as 7 to the power 83 minus 7 to the power 83 minus 83 c1 into 7 to power 82 plus 83 c2 into 7 to the power 81. Okay, then like this. So so like this, so I can write 83 c 83 c 80 83 c 80, then 7 to the power 3. Okay, so 7 to the, this is minus sign, no 80 means plus sign, then minus 83 c 81 7 square. Okay, then plus 83 c 82 7 to the power 1. Okay, then minus 1. Okay, so this is what would be this expression. Now if you notice in this expression, you are dividing by 49. So all the number except all the number except this would be the multiple, would give a reminder 0. Okay, because they all are more than or equal to 7 square. Okay, so only this what I highlighted, they are less than 7 square. Okay, so you're dividing by 49. So above it, everyone is more than 7 square or equal to 7 square. So they get be divisible. They'll give a reminder 0. So when you divide it by 49, okay. So except this. Okay. Now similarly, I can do the same thing for 8. So 8 to the power 83. Similarly, if I do the same thing to the power 8 to the power 83, that you can write as 7 plus 1 to the power 83, that is 7 to the power 83 minus 83 c1. So here this is all of plus 83 c1 7 to the power 82, like this 83 c2 7 83 c 82 7, and here plus 1. Okay, so ultimately what matters, all what matters, everything would be divisible. What matters is only this, and you know that n minus r is ncr. So 83c 82 is 83c1. I believe everyone understand this. So if you add them, so 6 to the power 83 plus 8 to the power 83 when divided by 49, if you all would be divisible, all will give a reminder 0 except 83c 82 7 minus 1 plus, so plus all remaining all will give remainder 0, then 83c 82 83 83, then again the same thing, 83c 82 7 plus 1 divide by 49. This gets cancelled. This is 283c1 into 7 divide by 49. Okay, so 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 this is 2 into 83 into 7 divide by 49. So 83, so here if I check this number, this is 7 2s are 14, 7 2s are 14, 14 into 83. 14 3s are 42 and 14 8s are 112. This is 112. This is 1162. This is 1162 divided by 49. So 1162 divided by 49. So 1162 divided by 49. 49 twos are 49 twos are 98. 49 twos are 98. 182. So 49 fours are 36. 196. 49 threes are 27. 147. 49 threes are 147. The remainder for this is 35. Next question. So what is the Toshin number of 125? Toshin number of 125 is 125 into 4 by 5. So 125 by 5 is 125 by 5 is 25. 25 into 4 is 100. So again that logic will not work here because here the number are 6 to the power 50. Okay, so 6 to the power 50. So here if I want to check 6 to the power 50 plus 4 to the power 50, when you divide it by 125, what is the remainder? When you divide by 125, what is the remainder? If you divide by 125, what is the remainder? Okay, so 6 I can write 6 I can write as 6 to the power 56. I can write as 5 to the power 1 to the power 50, and 125 is where the power of 5 is 3. So all the power of 5 less than 3 would not be divisible by 125. Okay, otherwise 5 to the power 50 plus 50 C1, then 5 to the power 49 plus 50 plus 50 C2, 5 to the power 48. So like this till 50 C46 or 47 till 47, 5 to the power 3. So till here everything would be divisible. Then 50 C48, 5 to the power 2. Okay, plus 50 C49, 5 to the power 1 plus 1. You know that. Okay. And similarly, I can write 4 to the power 50. So 4 to the power 50. I can write 5 minus 1 to the power 50. That is again 5 to the power 50 minus 50 C1, 5 to the power 49 plus 50 C2, 5 to the power 48. So like this, minus 50 C47, 5 to the power 3. Okay, plus 50 C48, 5 to the power 2, minus 50 C49, 5 plus 1. Okay, so ultimately if you add them, so what matters to you for calculation purpose is this. What matters to you for calculation purpose is this. If you add them, now you can notice this and this will get cancelled. If you notice, this and this will get cancelled. So ultimately I can say 6 to the power 50 plus 4 to the power 50 divided by 125. From adding, I am getting 2 times of 50 C48, 5 square plus 2, divide by 125. this I can write as 50c2 5 square means 25 plus 2 divided by 125. So 50c2 is 50 into 49 by 2. So 2 will get cancelled. So 50 into 49 into 25 plus 2 divided by 125. Now you know that this number definitely would be divisible by 125, because 125 is 5 cube, and definitely here you are getting, here 5 is there, 2 5 is there, here also 2 5 is there. So this is more than 3 powers of 5. Automatically they would be divisible. So ultimately the remainder for this problem would be the 2. The 2 what left, plus 2. Fine. So see the next problem. So 64, question number of 64 is 2 to the power 6. So 64 question number is 1 by 2. 64 into 1 by 2, that is 32. These powers are less than 32. So I can try Euler number on this. I can do it by binomial theorem. So, or I can apply Euler number, because 15 I can write as 16 minus 1, 7 I can write as 8 minus 1. Like that I can try through binomial theorem, or I can do this problem through by the Euler's theorem. Okay. So anyway you'll get the same answer. So this is 15 to the power 121 plus 7 to the power 124. If you divide by 64, so the quotient number of 64 is 32. So this is 15 to the power 32. Then how much power left? 121 divided by 32. Okay. 121 divided by 32. So 121 divided by 32. So 32 2s are 64, 32 3s are 96, 32 4s are 128, 32 4s are 128, 34, 32 3s are 96. So 21, this is 5, and this is 11, 25. So that here this is to the power 3 into 5 to the power 25 plus 7 to the power 32 to the power 128. Now was 128. This is 124. No? Same thing you're doing. 124 96, you'll get 28. 8 plus 6 14, so you'll get 28. Divide by 64. So this part will give remainder 1. This part will give remainder. So 15 to the power 25 plus 7 to the power 28 divided by 64. What is the remainder? So now the problem becomes like this. So if you divide by 64, so what is the remainder? So one power is odd, one power is even. So what I can do again, this now here I cannot use Euler's theorem also. So Euler's theorem also cannot work, because question number 64 is 32. So I cannot use Euler's theorem also. Now 64 I can write as 64 I can write as 64 I can write as 2 to the power 6. 15 I can write as 15 I can write as 2 to the power 4 minus 1. This is 2 to the power 3 minus 1. 2 to the power 4 minus 1. This is 2 to the power, this is 2 to the power 6. So 15. So I can write 15 to the power 25. So 15 I can write as 16 minus 1 to the power 25. So this is 16 to the power 25 minus 25c1, then 16 to the power 24, then plus 25c2, 16 to the power 23. So like this, we can check like this. We can check uh, their powers. Mm-hmm. Mm-hmm. Uh, this look a little bit complicated. So 1 minute. So 64, question number 64 into 1 minus 1 by 2, that is 32. So now what I can do to divide it by 64? So 64 I can write 8 into 8. So what I can do for this, I can write 64 as 15 to the power 25 plus 7 to the power 28. 64 I can write 32 into 2, or 8 into 8. I can write this as 8 into 8. So I can write this as 8 into 8, or 64 into 1, or 32 into 2, or 16 into 4, something like that. 16 into 4, anything I can write. So let's write them 64 as 16. 4s are 64, 16 into 4. Okay, so let's find the remainder. So when 15 to the power 25 plus 7 to the power 28, if I divide by 16, then what is the remainder? So here the remainder is minus 1 plus 7 to the power 28. If I divide by 16, what is the remainder? So 7 square is 49. If you divide by 16, the remainder you're getting is 1. 16 threes are 48. You can write 7 square to the power 7 square to the power 14 divided by 16. So this is 48, getting remainder 1, here getting remainder minus 1. Okay, so minus 1, you can write minus 1, or you can write 15 also. So you can do hard work for 15 part here. So I can write 15 to the power 115. The remainder is 15, 15 to the 225. If you divide by 16, so then 16 ones are 16. Then you are getting a remainder 1, no? 16 to the power 15 to the power 2. 15 to the power 2 is 225. So 225, if you divide by 16, 16 ones are 16. This is 65. 16 fours are 64. 16 fours are 64. One remainder. You can see here you're getting remainder 1. So here you're getting a remainder 1. So what I can do? So here what I can do, I can write this as 15 to the power 2 to the power 2 and 24 into 15 plus 7 to the power 2, 49 to the power 14 divide by 16. So 15 to the power 2 is 225 will give a remainder 1. So here what left is 15. Here what left is 15 plus here you're getting a remainder 1 divide by 16. So here you're getting remainder 0. Here you're getting 16 divided by 16 remainder 0. Okay, okay. Now the same thing, 15 to the power 25 plus 7 to the power 28 divide by 4. So what is the remainder? So what is the 4? What is the remainder? So 4, if you divide by 4, what is the remainder? So 4 3s are 12, 3 to the power 25, and this is 3 to the power 28 divide by 4. Divide by 4. So this will give a reminder 0. Again this will give a reminder. This will give a reminder 0. So 3 to the power 1, 3 to the power 9 is 3 to the power 9 is 8. 1 minute. 3 to the power 9. So 3 to the power 1. 3 to the power 1 is 3. 3 divided by 4 is minus 1. 3 to the power 2, 9. 9 divided by 8. 3 to the power. So 3 to the power 2 is 9. And this is 12. 24 into 3 plus 3 to the power 2 9, and 9 divided by 4. So that will give a reminder. So that will give a reminder called 1. So here you're getting a reminder called 3. Here you're getting a reminder. This is 9. 9 divided by 4 is 1. 9 divided by 4 is 1. Reminder 1 to the power anything is 1. So this is 3. Here you're getting a reminder called 1. So again here you're getting a reminder called 0. So here again you're getting a reminder called 0. So with 16 also you're getting reminder 0. Here also you're getting reminder 0. So with 16 also you got the reminder 0, and with here also. So here also with 16 also I wrote this number as 16 into 4. So with 16 also you get a reminder 0, and with 4 also you get a reminder 0. 16 4 is 64. Okay, so the answer for this problem would be 0 only. Clear? Anyone have any doubt? Anyone want to ask any question? Anyone have any doubt? Any question you want to ask? Clear? Anyone want to ask any question? So you can use reminder theorem, you can use Chinese remainder theorem, you can use Euler's theorem. So you can use any mechanism. Ultimately, the objective here is that you need to figure out how you can solve so that you can get the answer. So the same problem I can try the same problem by step approach also. So 15 to the power 121 plus 7 to the power 124 if you divide by 64, so what is the remainder? I can try manually one by one. So 15 to the power 1 is 15, and if you divide by 64, the answer is remainder is 15 only. 15 to the power 2 is 225. So 225 if you divide by 64, so 64 twos are 64 twos are 64 fives are is 320. 64 fours are is 64 fours are is 256. 64 threes are 64 threes are is 12 192. This is 192. This is 3. This is 3. This is 9 plus 3 12. So this is 3. So this is 33. This is 33. This is 33. Okay, so then 15 to the power 3. 15 to the power 3 is how much? 15 to the power 3. 15 to the power 3 is nothing but 13 into 15. 13 into 15 is what? 45 plus 45. 45 and then 45. 495. So 495 divide by 495 divide by 64. So 495 divided by 64 if you do. So 495 divided by 64 if you do. So 64 6 are 24 384. Then 64 8 are 32 512. 64 7 are 28 448. 7 are 448. 47. You can see complication reminder. You're getting complication. So 15 to the power 3, 47, then 15 to the power 4. If you try 15 to the power 4, that is 15 into 47. So 15 into 15 sevens are 105, and then 60, then 705, then 705 divide by 64. 705 705 divided by 64 ones are 64 ones are 64. This is 65. Then ones are 64 1. The remainder 1 you are getting. So 15 to the power 4 will give a remainder 1. Oh my god. I got a very big breakthrough. So 15 to the power 4, I don't know what is the value. So that is definitely 225 square. What is 225 square? That also I can find. What is 225 square? So 225 square, last two digits 25, then 22 into 23. 23 into 22, this is 46. This is 46. This is 6, 10, 506. This is 50625. And 50625 you divide by 64. 50625 you divide by 64. You'll get a remainder 1. So let me check that also. So 5062550, 506. So 64, 64 8s are 512. 64 7s are 448. 64 7s are 448. 8, and this is 9. 9 4 5 582. 582. 64 9s are 36. 9 6 are 54. 576. 576. 9s are 576. This is 6. This is 65. You can check. Remainder is 1. Okay, that is what I was telling. So 5 to the power 4 is giving you remainder 1. Okay, 15 to the power 4 is giving you remainder 1. Okay, what about 7? Let me check for 7 also. Let me check for 7. So 7 to the power 1 is 7. If you divide by 64, remainder is 7. 7 to the power 2 is 49. Remainder is 49. 7 to the power 3 is 343. So that is 343. So 343 if you divide by 64. 343 if you divide by 64, 64 fives are, that is 320. 64 fives are, that is 320. That is 23. That is 23. 7 to the power 4, that is 2401. So 23 sevens are 23, that is 23 sevens are divide by 6, that is 1 uh, 14 161. 161 divided by 64, so 161 divided by 64, so 64 twos are 128, 64 threes are 192, 64 twos are 128. So this is 3, this is 333. Okay. 7 to the power 5, that is 33 sevens are, 33 sevens are, that is 1 231. 231 divided by 231 divided by 64, 231 divided by 64, so 64 fours are, that is 256. 254, 64 threes are 192. 64 threes are 192. Then 12, 39. And then this is 39. 7 to the power 6. That is 39 6. 39 sevens are 63. 21 273. 273 divided by 64. 273 divided by 64. So 64. 64 forza. 64 forza is 256. 64 forza is 256. 256. That is 17. 7 to the power 7. 17 sevens are 119. 119. 119. 64. 64 twos are 8. 128. 64 twos are, you are getting bigger value. 64 twos are 128. You are getting 64. 64 twos are 8. 128. This 64. This is 5. This is 55. This is 55. This is 5 and this is 55. Then 7 to the power 8. 55 sevens are. 55 sevens are. 7 to the power 8. 55 sevens are. That is 35. 385. 385. 385 divided by 64. 385 divided by 64. So 64 fives are, you got 320, no? Then 64 six are, you get 24, and then this is 384. 24 36 38. 64 six are 384. You got the, I got the breakthrough, that is 1. That is 1. So you got the remainder 1. 7 to the power 8 is giving you remainder 1. 7 to the power 8 is giving you remainder 1, and 15 to the power 4 is giving you remainder 1. So 7 to the power 8 is giving you remainder 1, and 15 to the power 4 is giving you remainder 1. So 15 to the power 121 plus 7 to the power 124 divide by 64. So you know that 15 to the power 4 will give you remainder 1 when you divide by 64. So this is 30 into 50. So this is plus 7 to the power 8. So 8 means 1za. 8 means 1za. Then 1za means 44. 44 means 15za. 15 8 are 120 into 7 to the power 4 into divide by 64. Divide by 64. Okay. So you know that this part will give remainder 1. Ultimately what left? Ultimately what left? Ultimately what left is 15. 15 plus this end will give 1. This is 7 to the power 4 divided by 64. 7 to the power 4 is 2401. 7 to the power 4 is 2401 plus 15. So this is 6. This is 1. 2416. This is 2416 divided by 64. 2416 divided by 64. 2416 if you divide by 64, so 64 fours are then 24 to 56. 64 threes are is 192. 64 threes are is 192. This is 9. This is 4. 9 plus 4 13. This is 496. 64 nines are 9 fours are 36. Then 54. Okay, so this is 64 8s are 32 48 512. Okay, 64 7s are 28. This is 448. 448. This is you're getting 48 as the answer. Hmm. Hmm. So you are getting 48 as the answer. So for this problem, the answer what you're getting is 48. Okay, so you can ignore the first mechanism what I mentioned. You do like this. So the answer for this problem will be 48. So 15 to the power 121 plus 7 to the power 124. If you divide it by 64, so what you need to understand here, for this problem what I'll do, I'll check the power of 15. So I'll check the power of 15. 15 to the power 1 is 15, and if you divide by 64 your remainder is 15. 15 to the power 2 is 225. Okay, so if you divide by if you divide by 64, if you divide by 64, so if you divide by 64, so 64 192, no? 64 threes are is 192. So 192. So 8 plus 25. 25 plus 8. 25 plus 8 means 33. You will get a reminder. Then 15 to the power 3. 15 to the power 3 means 15 into 33 means 495. 495 if you check with 64. So if you check with 64, how much you will get? So 64 495 if you check with 64. So 64 5s are 64 6s are 7s are 7s are 7s are is 448. 8s are will be bigger value. So 448 means 495 minus 448. You'll get 7. You'll get 47. So you'll get 47. So 15 to the power 4. So 15 into 40, 47. 15 into 47 is 105 and then 60. So you will get 705. So 705. So divide by 64. So 705. If you divide by 64, you will get a reminder 1. 705 if you divide by 64. 64 ones are 64. This is 65. So you'll get 1. So you work all the hard work you will do to get the remainder 1. You get the remainder 1 means what? So 15 to the power 4 will give you remainder 1. So same work I do for 7. So 7 to the power 1 is 7. If you divide by 64, you'll get 7. 7 to the power 2 is 49. If you divide by 64, you'll get 49. 7 to the power 3 is 243. If you divide by 64, if you divide 343 by 64, so 320, so that is 320. So you get 23. So 7 to the power 4. So that is 23 sevens are 23 sevens are is 161. So 161 if you divide by 64, So 64 twos is 128. 64 twos is 128. 64 threes is 192. 64 twos is 128. So this is 3 and this is 333. So you get a reminder called 33. Similarly, if you find 7 to the power 5, that is 30, that is 231. 231. If you check 231, 64 Forza, 64 Forza is 256. That is bigger number. So 31, then 192. 64 Threesa is 192. So 192, 8 plus 31. 30, you get 39. Then 7 to the power 6. 39 sevens are 39 sevens are is 63. This is 273. So 273, if you check with 64, 64 Forza, 64 Forza is 256. 64 Forza is 256. So this is 246. So you get a reminder called 17. Okay, so 64 7, then 7 to the power 7. So 17 sevens are 119. 119. 119 means 64 twos are 64 twos is 128. So this is 119. So 64. So 119. So this would be 5s are. Then this would be 55. Then 7 to the power 8. 7 to the power 8 is 55 sevens are. 55 sevens are is 385. So 385. So 385. If you check with 64. So 385. You check with 64. 64 5za is 320. 64 6za 6za is 384. 64 6za is 384. So you get a reminder one. So 384. So 385. You're giving a reminder one. So my work is done. All the work, all the hard work I've done for that one. So this is 15 to the power. This is 15 to the power. This is 4 to the power 30 into 15 to the power 1 plus 7 to the power plus 7 to the power 7 to the power 8. So this is 15 8s are 120 into 7 to the power 4 divided by 64. So, so 15 to the power 4. 15 to the power 4 will give to the power anything will give a remainder 1. So here what left is 15. Here 7 to the power 8 to anything will give a 1. That is 7 to the power 4 divided by 64. Now 7 to the power 4 is 7 to the power 4 is 2401. If you add 15 in that, so you will get 2416. So if you add 15 on that, you will get 2416. So ultimately you have to check 2416. If you divide by 64, what is the remainder? This part you can do manually by yourself. So 2416 divided by 64. So 64 Forza, you know that Forza 64 Forza. So that is 256. 64 3za 192. 40. This is 9. This is 9. This is 9. This is 9 plus 4. This is 496. Then 64 9s up. 9 6 up, you get 54 something. 64 8s up. Carry also 64 7s up. If you see 7s up, 64 7s up. 28 448. So you'll get 8 and you'll get 4. You'll get 48 as the answer. So this is what you have to do for this problem. So the answer for this problem would be 48. So we'll do more class questions in next class. So this much what I have planned for this class. I hope you like this class. So if you have liked this class, don't forget to click on the like button and please subscribe to my channel to get more and more content on related to the quantitative aptitude. Thank you everyone. God bless you.